Okay, so here is the next problem right here. Okay, so it says a buffer solution contains 0.25 molarity of acetic acid. I'm giving you the hint that that is your HA, your weak acid, and 0.50 molarity sodium acetate. That's your conjugate base. The pH of the solution is 4.76. Determine the acid dissociation constant, meaning the Ka, for acetic acid. So let me make that one a little lowercase right there. All right, so here. All right, so here is your formula. pH equals pKa plus the log, okay, of your A over your HA. Okay, that's one thing you do need to know, right? Now, we're looking for the pKa. So you guys know what we have to do, right? They already gave us the pH in the problem. They gave us the A and the HA. We need to rearrange this problem to solve for our pKa. All right? We've got to rearrange this. See, you can actually plug the numbers in now, but I would rather you go ahead and rearrange the formula up front so you don't have to remember to do it for later. So I'm going to rearrange this problem because I'm looking for the pKa. I'm basically going to take the log and bring it to the other side of town. So I'm going to say minus the log of A. Let me go ahead and pull this up a little bit more. Okay. I'm going to plug this in over here on this side now, okay? So that I could get rid of this right here and I'm left with pKa on the other side. So I'm going to rewrite the formula so you all can see it in fashion, okay, in a proper fashion. So the pKa is equal to the pH minus the log of your conjugate base divided by your weak acid. Okay. So now what you have to do, you're going to plug in the numbers into your formula. So the A is going to be on top, 0.50, okay? So let me go ahead and put this here. So pKa equals, the pH they gave us was the 4.76 minus the log of, so on the very top, again, 0.50. On the bottom, so you can see it, 0.25. Okay, go ahead and divide those two numbers. Don't do the log yet, but divide those two numbers, okay? Plug it in to your calculator, okay? So you got 0.5 divided by 0.25. It gives you 2. So pKa equals 4.76 minus the log of 2. The log of 2 gives me 0.301. I'm going to take 4.76 minus 0.301. So 4.76 minus 0.301 gives us 4.46, okay? So the pKa is equal to 4.46. Get your Ka, because that's what we were solving for. You're going to say 10 to the negative pKa. So your Ka is equal to 10 to the negative 4.46. Then you should get, now I'm going to write it out, 3.47 times 10 to the negative fifth power. Okay, there you go. So that becomes your answer right there. Your Ka is 3.47 times 10 to the negative fifth power.